Hello there, this is Math 0018 and this is the practice final exam. So this is it, down to the last thing. So number 1, we have the absolute value of negative 75. So remember, absolute value is always positive. So the answer is positive 75. Number 2, 54 plus negative 93. The signs are different. So the rule is subtract and keep the sign of the larger number, which would give me a negative 39 when I subtract there. Now, number 3, we have subtraction. So remember, you want to do keep, change, opposite. So I'm going to keep the negative 9, change it to addition, and then the opposite of 7 would be negative 7. So the signs are the same. I add and keep the sign and get negative 16. Number 4, we're multiplying. So we have 3 negatives. That's an odd number of negatives, which means the answer is going to be a negative. So I multiply 7 times 6 is 42 times the 4. So that's 8, and 4 times 4 is 16. So you should get a negative 168. Number 5, this is that hard exponent problem. If there are no parentheses with that opposite sign there, remember you bring the sign straight down into your answer. It's going to be negative all the time, no matter what. And 9 times 9 would be 81, so negative 81. Number 6, we have to use the order of operations. So our first step here is we have to square the 4. Okay, and I do not like this problem because this is one that we had come up in the first chapter, and because the square is on the inside of the parentheses there, basically that base is just the 4, not a negative 4, and it's really confusing. So here's what might help you remember that. If the exponent is on the inside with the base, then what you need to think of here is negative 1 times 4 squared. Just separate that negative sign from the 4. So then what you have is we're going to start with that exponent, and we're going to have negative 1, and then 4 times 4 would be 16. Negative 1 times 16. So this is going to change it. It's going to, I just don't like this problem, so you'll have to be careful on this one. So we have 28, bring down the minus sign, bring down the 16, and the division. And now we're going to multiply negative 1 times 16 would be negative 16. So that's kind of confusing for a lot of people. Now look at what you have left, subtraction or division. So we're going to divide. We have 28 and the minus sign. 16 divided by negative 16 would be a negative 1. And then you want to do keep, change, opposite. Okay, so I'm going to come up here so I have some room, and that would become 28 plus positive 1, doing the keep, change, opposite, and that would give you 29. So hopefully the one on the final will not come up looking like that, because I do not like that problem, but you have to be careful there about that base in the parentheses. Now if the exponent had been on the outside, then you would have multiplied negative 4 times negative 4, and it would have been a positive 16. So just be careful about that one. Number 7, another order of operations problem. At least this one looks friendlier. So we're going to start with the 7 minus 1, the innermost grouping symbol. Okay, so bring down the 5 and the 14 and the minus sign. 7 minus 1 is 6. So I can now drop the parentheses because I've taken care of that operation. So our next step is to finish the brackets. So we're going to bring down the 5. You have to keep the brackets because that's multiplication with the 5 there. So 14 minus 6 is 8. Bring that down. Divided by 10. So we have multiplication and division. Remember, you do those left to right. So the multiplication comes first. So 5 times 8 is 40. And 40 divided by 10 gives me 4. Much better than number 6. I like that one better. Alright, number 8. Evaluate the variable expression when a equals negative 3, b equals 5, and d equals 1. So remember, this is where we plug it in and work it out. So let's see, we want to write b, which is 5, plus d, which is 1, squared, minus 5 times negative 3, because that's what a is. All right? So we're going to start in the parentheses. 5 plus 1 is 6. And still keep the exponent on the outside and bring down the multiplication. Okay? So the next step would be the exponent. So think about 6 times 6 would be 36 minus 5 times negative 3. Now the next step, if you take the sign with the 5, it's a lot easier. Bring down the 36, and when you multiply, say negative 5, take that sign with the 5. Negative 5 times negative 3 is a positive 15. So then when you add there, because if you kept the subtraction sign, you could have just changed the sign later, but it's a lot messier. So if you can multiply a negative times a negative, it's easier. So 36 plus 15 is what? 51. Okay? Now, number 9, realize this does not have anything to do with number 8. We're not evaluating. We're simplifying. These are all like terms, 9a, 13a, 2a. So you're going to work, you can work straight across, you can combine your like terms, the two positives if you want to. It's almost easier just to work straight across. So look at what you have here. You have 9 minus 13, a negative 13. So you're going to subtract there and keep the sign of the bigger number. So that's going to give you negative 4a plus 2a. Now a negative and a positive we subtract and keep the bigger sign, which would give you negative 2a. Number 10 says to simplify, and we have 2 times x squared minus 3x plus 6. So this is where we have to use our distributive property with the 2. So you're going to multiply 2 times x squared, and then that's a positive 2 times a negative, bring that sign with it, negative 3x, and a positive 2 times positive 6. So 2 times x squared is 2x squared. Now, multiply before you write your sign. 2 times a negative 3x would be negative 6x. So that sign changed there. Be careful, okay? And then 2 on the last step, 2 times 6 would be positive 12. And there's no like term, so that's your answer. Number 11, translate into a variable expression. 9 times the difference between x and 7. So we have two keywords here, times and difference. So we want to do 9 times the difference, the whole difference, which is another operation. So we have to write 9 and parentheses. Very, very important to have the parentheses there. Now, difference is subtraction. So you put your subtraction sign there. And you want the subtraction between x and 7. So we have x minus 7. Now, it did not ask us to simplify, so you don't have to do that here. You just have to translate it. Number 12 says to solve and check this equation. So we have b minus 2 equals 15. So if we want to get the b by itself, we need to get rid of the negative 2. So I'm going to add 2 to both sides. So the b comes down, 2's are gone, and it equals 17. Number 13, we have 2/3 x equals 8. So you want to get rid of that 2/3, that fraction. Remember, anytime a fraction's right beside a variable, you always have to use the reciprocal. So we're going to multiply both sides by 3/2 times 2/3 x, and then on the other side 3/2, and we're going to put 8/1. Okay? So on the left, everything cancels to little ones and you just get x. Okay? If you don't, that tells you you're screwing it up. You're doing the wrong thing. On the right, we don't have to worry about any signs, but we can cancel by 2. 2 will go into 2 once, and 2 goes into 8 4 times. So we have 3 times 4 would be 12. Number 14 says to solve and check. So we have 3x minus 7 equals negative 13. the first step, don't mess with the 3x. We want to get rid of that constant. So I'm going to add 7 to both sides. So 3x comes down, and negative 13 plus 7 would be negative 6. You have to subtract there and keep the bigger sign. Then divide by 3 on both sides. So x equals negative 2. Number 15, we have negative 2y plus 14 equals 14. So we're going to start by getting rid of the 14 that's on the same side with the variable. So I'm going to subtract 14 from both sides. So negative 2y comes down. The 14's cancel, and you have to be careful over here. Yeah, the 14's on the other side cancel, but you have to write a 0, because otherwise you've lost half of your equation. You have to have the other side. And now, still do the same steps. Divide by negative 2. Okay? And we get y equals 0. So when students get a 0 in a problem like that, it kind of freaks them out. So don't let that bother you. Number 16, solve and check. So we have variables on both sides of the equal sign. 15x minus 6 equals 4x minus 17. So my first step, I want to get my variables together on the left. So I'm going to subtract 4x from both sides. So 15 minus 4 is 11x minus 6, and then that equals negative 17. Now we move the constant. So I'm going to add 6 to both sides. So 11x comes down, the 6's are gone, and negative 17 plus 6 would be negative 11. And then your last step would be to divide by 11, so those cancel, and x equals negative 1. Alright, number 17 is a proportion. So remember, with a proportion, you have to cross multiply. Okay, so we're going to have 3 and then in parentheses n minus 5 equals 8 times 6 would be 48. That's what you get on the other side. So now we need to distribute the 3. So that would be 3n, and 3 times negative 5 would be negative 15 equals 48. Okay, so now the next thing we need to do, don't mess with the 3n, get rid of that 15. Add that to both sides. So 3n comes down, the 15's are gone, and 48 plus 15 is what? 63. And your last step would be to divide by 3. So n equals 21. Number 18 says a life insurance policy costs $16.51 for every $1,000 of insurance. At this rate, what is the cost of $70,000 of insurance? So we are setting up a proportion here. It's at this rate tells you definitely set up a proportion. So I want to set up the cost, how much it costs, over basically how much insurance you get. So it says the policy costs $16.51 for every $1,000. Okay, and then they want to know what is the cost of $70,000 of insurance. So we want to know the cost, that would be X on top, and we're going to put 70,000 on the bottom. All right, crack out those calculators. Okay, so we have 1,000 X and then 16.51 times 70,000 turns out to be a really big number. Let's see, 1155700. Okay, which is what? 1,155,700. All right, now then we divide by 1,000 and we get 1,000. Oops, let me write out that 1,000 there. Divide by 1,000 on both sides. So x equals $1,155.70. So it's a lot of money. Of course, $70,000 of insurance is a lot of insurance. Number 19, find the prime factorization of the number. So remember, this is where we use the factor trees, okay? So 36, I'm going to split that into 6 and 6. Could I have used 9 and 4? Yes. 3 and 12? Yes. 2 and 18? Yes. Any of those, okay? I'm going to use 6 and 6. Then 6 can break down into 2 and 3, and those are both prime. And the other 6 also breaks down into 2 and 3. So then your prime factorization would be 2 times, oops, that was a mess. Let me start that over. I need an eraser. 2 times 2, I almost did it again, times 3 times 3. You don't have to put them in numerical order. You could have said 2 times 3 times 2 times 3, as long as you got them all in there. That's what's important. Okay? Now, number 20. Find the least common multiple, the LCM of 12 and 14. So we need to start by prime factoring, that's, I guess that's a word, 12 and 14. So I'm going to do 12 right here. I'm going to use 3 and 4. 3 is prime. 4 would be 2 and 2. Circle those. Those are prime. And then 14, when we break that down, that's 2 times 7, and those are both prime. So now remember, this is a long time ago. 12, you write it out in a line. 2 times 2 times 3. And 14 is 2 times 7. So finding the LCM, this is where you circle long ways, horizontally, okay? And you pick the biggest number of each factor. So we've got 2s, 3s, and 7s. So I need a 2 circle, a 3 circle, and a 7 circle. I need 3 circles. Well, the biggest number of 2s is on the top. So I'm going to circle that, okay? Both of those. You have to circle the 3 because it's different. And I also have to circle the 7. So now notice I circled the entire top line. Well, the top line is equal to 12. So I have 12 times 7, the other circled number, which gives me 84. And that's the least common multiple, which is also the same thing as the least common denominator. 21. Find the GCF. So here you're looking for the biggest number that goes into both 6 and 40. So again, we start with prime factorization. So 6 would just be 2 times 3, and they're both prime. I'm going to do 40 over here, so I've got some room. I'm going to split it into 5 and 8. Okay, 5 is prime. 8 would be 2 times 4. So that would be 2 is prime. 4 would be 2 and 2, and those are all prime. Okay, so I want to write them out in a line. 6 is 2 times 3, and 40 is 2, 2, 2, and a 5. Okay? Now, to find the GCF, remember you circle vertically up and down what they have in common. So the only thing they have in common is a 2. You do not multiply 2 times 2. You just say, what do they have in common? A 2. So the GCF is just 2. Okay? Another way to practice and check this is if you tried to multiply those 2's together, you would get 4. Does 4 go into 6? No. So how can it be a common factor? So double check yourself so that you don't screw that up. Okay? Number 22. Write the fraction in simplest form. So we have 12 over 45. And at first, when you first look at that, you think, well, nothing will go into both of those. They're not both even, so 2 doesn't work. But the next prime number up is a 3, and 3 goes into both of those. So I'm going to divide the top and bottom by 3. 12 divided by 3 is 4. 45 divided by 3 is 15. And there's nothing that goes into both 4 and 15. So that's your answer there. Okay, 23. Now we're getting into a lot of fractions. So it says to add 2/5 and negative 14 over 15. So remember, the two operations where you need a common denominator are adding and subtracting. So we're going to have 2/5, and I'm going to put them vertically so that I can come out here and get a common denominator. All right, and negative 14 over 15. So 5 and 15, my common denominator is 15. That's my new equivalent denominator. So 5, I have to multiply by 3 to get 15. So 2 times 3 on top would give me 6. And then on the bottom fraction here, 15 times 1 gives me 15. So I have negative 14 times 1 would be negative 14. Now, they're both over the same denominator now, so now you look at your numerators. 6 and negative 14, I'm going to subtract and keep the sign of the bigger number, which would be negative 8 over 15. And you can't reduce that, so you're done. All right? 24, we're going to multiply fractions. So, the first thing, everybody's like, oh, you got to cancel. Even before you cancel, figure out your sign, okay? Hey, baby, what's your sign? So what's a negative times a negative? That's right, that's going to be a positive, okay? And let's see, we can cancel everything here. I can cancel 3 and 9 by 3. That's going to leave 1, and 3 goes into 9 3 times. 2 and 4 I can cancel by 2. 2 will go into 2 once, and 2 will go into 4 2 times. So I have 1 over 2 times 1 over 3, and I don't have to worry about signs because I already figured it out. Now you multiply straight across the top and across the bottom, so you get 1 over 6. Number 25, we are dividing fractions. So this is where we do keep, change, flip, okay? We keep the first fraction, negative 4/9, exactly the same. Change it to multiplication, and we flip the second fraction. So it's going to become negative 5 over 4. Alright, so now it's multiplication. A negative times a negative is going to give me a positive. And the only thing I can cancel the 4s. 4 divided by 4 leaves 1, and 4 divided by 4 leaves 1. And so now we have 1 times 5 on top is 5, and 9 times 1 on the bottom is 9. So a positive 5/9 is your answer. Number 26 says add or subtract as indicated. Write your answer as a mixed number. Okay, so this is where anytime you're dealing with mixed numbers, remember the rule is first step, change them to improper fractions, and then you just have a fraction problem. So remember, you multiply and then you add. So 4 times 10 is 40, plus 1 is 41 over 4. And I'm going to write them vertically so we can get the common denominators, all that stuff. And then on the second one, 10 times 7 is 70, plus 9 would be 79 over 10. And we're subtracting these. I don't even have to change the signs because 10 is bigger than the 7, so I'm okay to just keep it as subtraction. Now, look at 4 and 10. What will they both go into? And at first I was thinking 40 at first, just off the top of my head, but then I thought about it for a second. They'll both go into 20. So it's a little bit smaller. I'm going to use 20. So you've got to figure out 4 times what is 20? Times 5. So now multiply the top by 5. And let's see, what is that? 205. Big number. Okay. Alright, and then down here, 10 times 2 gives me 20. So I have to multiply 79 times 2. Let's see, that's 18, 158. Okay? And they're both over 20. So now what I want to do is subtract 205 minus 158, and that gives me 47 over 20. Now, you're not done because they wanted your answer written as a mixed number. So now we divide 47 divided by 20. 20 will go into 47 2 times. That's 2 times 20 is 40, and that leaves 7. So remember your mixed numbers in a circle here. Okay, you start at the top. That would be 2 and 7/20, and that's your answer. Number 27. Find the following quotient. So we have 16 divided by 3 and 1/5. So the first step is you want to change that mixed number to an improper fraction. So I'm going to keep it as division for now. 16 over 1, just write that as a fraction there, and then change 3 and 1/5 to an improper fraction. So 5 times 3 is 15, plus 1 would be 16 over 5. Now, it's still division, so now you want to do keep, change, flip. So, we have 16 over 1 times 5 over 16. You flip the second one only. We don't have to worry about any signs. So I'm going to cancel my 16s by 16. That just leaves 1. On top we have 1 times 5 would be 5 over 1, which is just 5. Number 28. You've got to be careful here. Even though it's decimals and everybody says, oh, that's easy, they get mixed up on the signs. So I'm going to change this subtraction sign at the end here. I'm going to do keep, change, opposite on that. So I'm going to keep negative 8.8. I'm going to keep positive 797. But now that's the keep. Change it to addition and take the opposite. So it becomes a negative 14.7. Okay, so I think what I would do at this point is I would add my two negatives. I have 8.8 and I'm going to add 14.7, and that's going to give me a negative 23.5, okay, plus 7.97. I just bring that down. So now you have a negative and a positive. So the rule is you have to subtract and keep the sign of the bigger number. So when you do that, you're going to have a negative because the 23 is bigger, and you're going to get 15.53. Okay? Number 29. Negative 1.4 times 4.7. So a negative times a positive is going to be a negative. And then don't put any signs in your calculator. Just put in 1.4 times 4.7, and you should get 6.58, and it's a negative. All right. Number 30. You had a balance of $360.38 in your checking account. You then made a deposit of $189.55 and wrote a check for $65.89. Find the new balance in your checking account. So we're going to start with the $360.38. Now, if we make a deposit, that's money added into our checking. So we add that. Okay. So let's see what that is. We have $360.38 plus $189.55 gives me $549.93. Now, then I wrote a check for $65.89. So I'm going to take the $549.93 and subtract $65.89, and that should give me the balance. So now if I subtract the $65.89, I get, if you can put the dollar sign in front if you want, $484.04. All right, 31. Write 44% as a decimal and as a fraction. Okay, so as a decimal, the decimal point's back here at the end, so I have to go 2 places to the left, which would give me 0.44. And remember, you drop your percent sign. And then for the fraction, remember percent's always based on 100, so you're going to put 44 over 100. Okay, and then I can reduce that. 4 goes into both of those. So divide by 4, and we would get 11 on top and 25 on the bottom. So there's your two answers there. Number 32 says write 0.75 as a percent. So remember your shortcut to help you here. You have 2 places. If we start with a decimal, we're doing the bottom arrow. We're going to the right 2 places, and it would be 75%. And number 33, the last problem. Woohoo! Can I get some applause? Drum roll. The whole bit. Do the wave. Whatever, okay? Convert the fraction to a terminating or a repeating decimal. Place a bar over any repeating digits. So we do 4 divided by 11 in our handy dandy calculator, and you get 0.36363636 forever and ever. So you have to put a bar over the 3, 6 because that is what repeats. So it has been very interesting making these videos for you this semester. Actually, it's been a lot of fun. So good luck on the final. You can do it. You can do it. Okay? I believe in you. So believe in yourself. You guys are all math nerds, and I'm very proud of you. Peace out. That sounds really dumb. But anyways, Miss Westner, and I'll check with y'all later. Good luck on the final.